Hi, welcome back. This is a series of videos that I'm doing on JavaScript execution context, this keyword, and this is the final video. In the previous videos, we've seen how normal functions work and how they take this context based on how we invoke the functions, and how it doesn't matter where you declare those functions, the location of the functions. We've seen many examples of how these normal functions behave, and we've seen one particular example where a child function which is declared inside a method is actually going to point to the global window object when we refer to this context. And we've seen a couple of ways we can overcome that issue in the objects methods when we are having these child functions within those methods. And in today's video, we're going to get introduced to how arrow functions behave with regards to the execution context, and what is the difference between arrow functions and normal functions with regards to that. And also we'll see some examples, and we'll also proceed how we can actually resolve that issue that we saw earlier with functions declared within the methods. As you can see, if I read it out loud, so the normal functions, as we know, as we have seen in the previous videos, they take this context based on how they are invoked. Very important. They take it on how they are invoked, the normal functions, and not based on where they are declared. Where they are declared, it doesn't matter. The declaration can be anywhere. Can be in the same file within the method, within a sub function, or within another sub function, or it can be in another file altogether, and it can be from within a function within another file, or whatever it can be. The location doesn't matter. All that matters is how we execute it, right? We've seen that. But for arrow functions, this is the tricky part. They take the execution context, this context, based on where they are declared. Okay, so think about it. The normal functions don't care where they're declared, but the arrow functions do care only about where they are declared with regards to this context. They take this context based on the enclosing scope, enclosing this context scope. Enclosing function. If there is a function in which you write an arrow function, it is going to take the scope of that function when it comes to determining this context, the execution context. And they're not based on, they don't take the context based on how they are invoked. It doesn't matter how they're invoked. We've seen there are three ways of invoking it. Invoking a function, be it normal or arrow function, doesn't matter. We've seen that there is this normal execution where you put the function name in parentheses. There is the object method invocation, and there is this bind method, bind function that we can use to create a new function. Then you can execute that function. We can use .call, .apply. All these ways are there. It doesn't matter for arrow functions how you actually invoke the function. Only thing that matters is where you declared it. So it's kind of the opposite of the way normal functions work. So it is really important that you understand this concept. So let's quickly look at an example. So I'm copying some code, and let me paste it in the JSPin online code editor that we have. We have the JavaScript console and the normal console, and looking at this code, it's a normal function. It's an arrow function declared in a normal way. It's just a variable declaration. By the way, you can only declare arrow functions like this. You can't use the function keyword, right? So they're always anonymous, and they're assigned to variables like this. And here in this function, all that it is doing is it's comparing the current execution context, the current this, to the window, whether it is equal or not. On line number 5, you can see we are executing the function in the normal way, most normal way. So if I just comment out the rest of the code and execute this bit, the output is true. It means when you execute like this, it is equal to the window. So because it doesn't matter, because this function is actually declared within the root level, within the scope of the window. That's why this is equal to the window. let's take another example. Let's comment this out. Let's take this example. Here what we are doing is we are declaring a variable object, and then we are object literal we are declaring, and then there is a prop foo, and then the foo function that we declared earlier is a member method now. Okay, so and we are executing in this fashion method invocation, right? We have seen method invocation in the previous videos, but it is not going to bind the obj object to the this context of the foo function, as we will see now. If I run it again, it is true. Let me clear it out and run it. True. So it is still equal to the window and not the obj object. So doesn't matter how you invoke it for arrow functions. Since it is declared in the global context, it is going to always take the global context, this to the window. Okay, let's try to do something else. Let's come back here and comment out this one, uncomment this one. Right. So here what we are doing is, okay, let's also uncomment this object because we're referencing that. So we have taken that method and we try to explicitly bind it again to the object. Hopefully, we're desperate. We want this foo to take the object, but the fundamental point, the difference point here is that we're using an arrow function and it's never going to work, but we're desperate, so we tried this. We take the method, which is we could have as well taken the foo function itself, which we're doing in the next example, but what we're doing here is we're taking the bind and explicitly forcefully binding the function to the object obj, and let's see if it works. It should print false if it is not equal to window, but it prints true. So again, this didn't work. Again, this function is still pointing to the context where it is declared, right? And finally, let's look at this example as well, where we're taking the function itself and trying to forcefully bind it to the object, and let's see. Still, the context is equal to window. So what does this tell you? No matter how you execute, invoke a function, invoke the foo function, it is always going to take the execution context from where it is declared. And incidentally, this is declared in the root level, which where this context is the window. Okay, does that make sense? Hopefully that makes sense, because this is the only difference between this one and the normal functions. So let's come down. Let's take another example here. What we're doing is, what if we declare it in a function, right? What if there is an arrow function within a normal function, right? Now this is a tricky part. Now this is really important to understand. Okay, we said that where we declared the function gives arrow function gives this context to that arrow function, right? Doesn't matter how we invoke it. So this is an example of that. So here I can say now the arrow function totally obeys the enclosing scope. Now it's not now, every time, right? It only obeys to the enclosing scope and not the way we invoked it. What do I mean by enclosing scope? It is exactly where it is lexically declared, right? Where it is physically declared in the file. Right, so that is the enclosing scope. This context is taken from there because it is declared inside it. So let's take this example, go back, paste it. So here the bar function is an arrow function and it is declared in the normal function foo, right? So we know that we can affect the foo function's execution context based on how we invoke it. So bar function, since it is declared in the foo function, right, and since the foo function is a normal function, the way we invoke the foo function actually affects the execution context of the bar function, right, because it is declared inside it. So when we invoke it like this normally, and for normal function executions in a normal way, it is going to always refer to the global object. So if I comment this out and run it, clear it, run it, command foo function. Okay, so what we'll do is we're going to run bar as well, yeah, because this is required, otherwise there's no output. When we run it, it is true. because we are executing the normal function, the non-arrow function, foo function, in the normal way, and when you do that, it is going to point to the global object. That is the rule. That is how we know it, right? So go back to the previous videos and look for this explanation if you're not sure why this is happening. And let's look at this object invocation. Now let me comment out. So going back to this example where we have an object, and the foo is a method. Now this foo is taken in as a method of that object, and we are executing the method now. So now, since the foo function is executed in the method context, it is going to take the obj object as its context, and since bar is part of the function declaration of foo, bar is going to obey that, and this will point to the obj object. Okay, so now I'll clear it out and run it. Now, so since this points to obj, this is not equal to window, so it gives false, right? Does that make sense? Yeah, so that is how it works. And the third example, let's do this. So here we take a new function using the bind syntax, and this is the third type of invocation that we're doing, and we're passing a different object here, so which is not the same as the window. So now also the outer function, foo function, has bound a different context which is not the same as window. So the bar is going to obey it. Okay, it's going to talk to foo and say, whatever be your execution context, give it to me. And foo gives this empty object now, and then bar accepts it happily and tries to use it. I mean, in this case, checking whether it is equal to window or not, and gleefully it'll print false because it's not equal to the window. Now if we pass window here, and it'll be true, because that is exactly what it's going to obey. The bar function doesn't have its own opinion about the window, this context. It is going to take whatever is the this context the enclosing function gives it, right? So yeah, so this is a tricky part, because now you can affect the bar's execution context based on the enclosing function's execution context. Okay, so really important. Now let's go to one example, one scenario that we checked in one of the previous videos, where we have an inner function, which is a normal function we had earlier. Now the inner function, in that example, in that video, we saw that the inner function did not get the execution context from the enclosing method function, but here, since we are using arrow functions, now we know that the arrow functions obey the execution context of the enclosing scope, which is the method here. It is going to gleefully take this context from the foo function. Why? Because we are executing the foo function using this syntax, right? Come to line number 12. This foo function is executed in the method invocation syntax. So when this function executes, its context will be obj, and since bar is an arrow function, it is going to take the context from its enclosing function, as we saw, and so this equals obj. So this will be true. This will anyways be true because it's a method and we're invoking it in a method. Arrow function also works because it is an arrow function and it takes the enclosing scope, right? Let's do something crazy here. So I'm going to say foo2 equals to obj.foo, right? Now I'm going to say foo2, right? So here I'm taking this function and executing it outside the context, outside the obj context. So now this is false, and so when I say this is false, this currently points to the in this case it points to the global object, and so since this points to global object in this function itself, in the enclosed arrow function also the same context comes, so it also equals the global object. So we'll see two false statements printed, or one statement because we're not executing bar again. right? So when we do that, we have to say const bar2 equals to that, and then we execute bar2 as well. Now we will get 2 truths and 2 falses. So does that make sense? So suddenly we've changed the foo functions behavior by taking that as a reference out of the context of the obj object, and we're executing it normally. And since it's a normal function, its location doesn't matter, only its execution matters. And when we execute it in a normal way, it is not going to take the context of the object. It is going to take the context of the global object, because it's a normal way of execution. So the global object is the window. So now this will be equal to window, not the obj, so that will be false. And since it is equal to window, the enclosing scope of the bar function is now having this pointing to window. The bar function also gleefully obeys that, and this also points to the window object. So both of them are false. Does that make sense? It's a tricky one, but it's really important that you understand this, right? So yeah, so earlier in previous examples, when we had to fix the issue with an inner function not taking this context of the enclosing method, we used a variable, self variable there, using the scope, using the advantage of scope. And we also did something like when we exported this, we bound the bar method or function to the object again using the .bind syntax. This is the third fix that we did. So we did not discuss it at that time because we did not introduce arrow functions and how they worked. But now this is third solution. You can use an arrow function and it will gleefully take this context of the enclosing method, which is the object. So this is also a fix for that kind of an issue. When arrow functions came in ECMAScript 6, this was primarily thought to be the reason why those functions were introduced, but I think it could be one of the reasons. But it's a whole new way of thinking, and then you can use it in all types of scenarios similar to normal functions. Only the difference is that how this context actually is taken, whether it is taken based on where it is defined or how it is executed. Right now we know that, right? Hopefully we know that. Okay, so that brings us to the conclusion of this video series. Hopefully you liked it. Hopefully I presented it well. I've used these tools, and let's quickly recap what we learned throughout this series. So we learned that we can declare normal functions anywhere in the program. It can be in the same file, different files, in a library, out somewhere. If you declare them in the object functions, object methods, make sure that you fix this context issue that we saw, or we can use arrow functions. Use the arrow functions for functions inside methods. We saw that just before. You can invoke normal functions in 3 ways. We saw the normal way, the object method way, and the explicit binding way. The arrow functions do not care how you invoke them. They only care where they are declared, right? So it doesn't matter how you invoke them ever, right? If it is an arrow function, doesn't matter how you invoke them. You might as well invoke them normally, right? And use the use strict mode to avoid accidentally polluting the global context and creating weird bugs. So that's all. That's it for this tutorial series. I'll keep making new tutorial series, new concepts, I'll take other concepts and try to explain them to you in simpler terms with examples and with content like this. If you've enjoyed it, please consider subscribing to my channel, giving me a like and a comment. Tell me how I did well or how I did bad. Both of them I can take. I'll take all the feedback and I'll try to improve on them, and hopefully I'll see you around. Thanks for watching.